This is the short version of practice problem number 1 from lesson 5, coordinate moves, and unit 1, rigid transformations and congruence. In problem 1, you are going to look at 3 transformations. Now, transformation is the big idea. It is the movement of an image, but maintaining that image's rigid form. So there's no bending or stretching. It's just a movement of that image, either by translating, which is part A, reflecting, which is part B, or rotating, which is part C. And in this case, for A, you're going to translate coordinates A, B, and C, which means to move them straight across the grid. And in this case, you're going to move them right by 4 units and up by 1 unit. That is a translation. You're going to label the new points A prime, B prime, and C prime. Here are those 3 points with their labeled coordinates, and the directions say to move each of these points to the right 4 units and up 1 unit. And I didn't mean to do this, but I actually did it in the reverse order. The order does not make any difference. So I moved each point up 1 unit and to the right 4 units. It would have been the same had I moved it to the right 4 units and then up 1 unit. I still would have ended up at this point A prime, which is coordinates -2, 6. And the same is true for B and C. So up 1 unit to the right 4 units, up 1 unit to the right 4 units. I could have gone to the right 4 units and up 1 unit, would have ended up at the same spot. Up 1 unit to the right 4 units, or to the right 4 units and up 1 unit again, ended up at the same position. And so you can look at this as a triangle, and that triangle, every single point within the triangle or on the sides of the triangle moves in the same way. That's why it's called a rigid transformation. In this case, that's a translation. So moving along this diagonal from point A to A prime, from point B to B prime, and C to C prime. And so you end up here, and that is the rigid transformation called a translation. Part B is a reflection of these 3 points, D, E, and F, over the y-axis. So the y-axis is the line of reflection, and a reflection is a second kind of rigid transformation, which means no bending or stretching. It's just a movement of these 3 points over this line of reflection, which is the y-axis. So here are these 3 points with their coordinates labeled. So this is D, E, and F. And this is the line of reflection. This is the y-axis. And so reflection means that each point is going to move perpendicular to the line of reflection. So a 90-degree angle and an equal distance on the other side of that line of reflection. So D is going to move in a perpendicular direction towards the line of reflection, 90-degree angle, and end up 3 units on the other side of the line of reflection. Now notice what happens to the coordinates. Since D is reflecting over the y-axis, the y-coordinate is going to remain the same. It is as if you travel up the y-axis to a +3, and in the first case you take a left turn and go to -3 for the x-coordinate. But what if instead of turning left to go to the -3, you turn right and go to +3? That is the reflection over the y-axis. So the coordinates, the y-coordinate remains the same as 3, but the x-coordinate switches signs. It goes from a -3 to a +3. So a -3 to a +3. And it is the same for E. So E, you don't travel anywhere on the y-axis because the y-coordinate is 0. But instead of going to the right 5 units, you're going to go to the left 5 units. So you're going to end up at -5. So in this case, again, the y-coordinate remains the same because that is the line of reflection, but the x-coordinate switches signs. So instead of going to the right in a positive direction, you go to the left in a negative direction. So E prime is negative 5, 0. And finally, it is the same for F. So along the y-axis, which is the line of reflection, you're going to go down negative 2 units. But instead of going to the right, so a positive 2 units, you're going to go to the left, which is a negative 2 units. So F prime, the y-coordinate is the same because you're going into the same position along the y-axis. You're just going in the opposite direction for the x-coordinate. So this is a negative 2 rather than a positive 2. And again, you're moving in a perpendicular direction to the line of reflection and an equal distance on the other side of that line of reflection. So this is positive 2 for the x-coordinate, and this is negative 2 for the x-coordinate, and the y-coordinates are the same, again, because you're moving along the y-axis. And finally, you can look at this as a triangle, and every single point is moving in a perpendicular direction to the y-axis and an equal distance on the other side of that line of reflection, the y-axis. So this is the reflected triangle, reflected over the y-axis. You look at it long enough, you can start to see this flip over to here, and this point flips over to here, this point flips over to here. So every single point within this triangle and on the sides of the triangle move in a perpendicular direction to the y-axis and an equal distance on the other side. The last rigid transformation is a rotation 90 degrees clockwise. So each of these 3 points, G, H, and I, are going to rotate 90 degrees in a clockwise direction, which means like a clock, which means in this case to the right. The center of rotation is the origin, 0, 0, and it's a 90-degree rotation. There are several ways to show these 90-degree rotations. One is to use patty paper or tracing paper. And so you lay the tracing paper over the figure, trace this line segment right here, and also you need to trace the 90-degree angle. So trace the y-axis, and I would go all the way down here, and trace along the x-axis. So the y-axis is going to rotate 90 degrees to the x-axis. So now put your pencil right here and rotate the tracing paper or the patty paper 90 degrees until this y-axis lines up with this x-axis. This is going to drag this point right here 90 degrees over here, and that will be a 90-degree rotation clockwise. So a clockwise 90-degree rotation. And you can see that this angle right here is the same as this angle right here. Another way to show this is by using an index card. So use the corner of an index card or any other corner that you can find. That's 90 degrees. So just line this up with this line segment right here, and then draw this line segment right here. You just have to measure the length. So make sure that you go out the same length. And that is a 90-degree rotation clockwise. You could use a protractor. You could use a protractor. So line up the origin of the protractor, line up 0 degrees along this line segment, and then measure 90 degrees over here. And again, you just have to make sure that you measure the proper length and put the point right here. A protractor, by the way, is useful for looking at the rotation of any number of degrees. So 10, 20, 30, 110, 120, 130, and so on. And the last way is to just use a counting strategy. So I counted over 1 unit to the left and 3 units along the y-axis to locate this point here, -1, 3. And so if I'm going to count 1 unit to the left along the x-axis, I can rotate that 90 degrees and count 1 unit along the y-axis and then 3 units along the x-axis this way. So that will be a 90-degree rotation. So 1 unit over to the left, 3 units up, rotate 90 degrees, count 1 unit up along the y-axis and 3 units over along the x-axis, a 90-degree rotation. And notice that as you move along the x-axis a -1 unit, that switches to the y-coordinate and it switches signs. It becomes a +1. So this -1 becomes a +1, and this positive 3 here remains a positive 3, but it switches from the y coordinate to the x coordinate. So the coordinates switch places. This negative 1 becomes a positive 1 and becomes the y coordinate. This 3, the y coordinate, becomes the x coordinate, but still keeps the same sign as positive 3. So this is a 90-degree rotation. The second one, h to h prime. H is located along the x-axis at a -4 units, so this is -4, 0, and rotates 90 degrees, and now is located along the y-axis, so it moves to 0, +4. So notice that, again, the x-coordinate switches, so you can count out 4 units along the x-axis, 1, 2, 3, 4, and then rotate this 90 degrees, and just count up 4 units along the y-axis, 1, 2, 3, 4. And notice that the coordinates, again, switch places, and the x-coordinate becomes the y-coordinate. So it moves from -4 to +4. So this x-coordinate becomes the y-coordinate, changes signs, and the y-coordinate becomes the x-coordinate. So the coordinates switch, and the x-coordinate switches signs. And the last one, I to I prime. I'm going to count along the x-axis, +3, and along the y-axis, -2. So this is at 3, -2. I'm going to rotate this 90 degrees and count down 3, 1, 2, 3, and along the x-axis, a -2. So notice again that the coordinates switch places, so this x-coordinate becomes the y-coordinate, and it switches signs. So this x-coordinate right here becomes the y-coordinate, and it becomes a -3. So it switches signs, and they switch places. So this 3 goes to -3, and this -2 remains the same, still -2, but it becomes the x-coordinate. So this -2 right here remains the same, so it's a -2 over here, but now it becomes the x-coordinate to get to this point. Now this might be easier to see if you look at rectangles and look at the diagonals of those rectangles. So this is G to G prime, so this rectangle rotates 90 degrees over to here, and this diagonal also rotates 90 degrees. This is not a rectangle, it's just a line along the axes, but you can see that this rotation is 90 degrees from the x-axis to the y-axis. And the last one, this rectangle here, rotates 90 degrees. So this diagonal goes 90 degrees over to here. So this point remains the same as the center of rotation, but this point rotates 90 degrees over to here. This point, I, rotates 90 degrees to I prime, and this point right here rotates to this point right here.